This is the oxidation of another primary alcohol. Remember, this is a primary alcohol because the carbon that contains the alcohol is connected to just one other carbon. So we're doing the oxidation of a primary alcohol. This alcohol has 1, 2, 3 carbons, or we should count from here, 1, 2, 3. So this is called 1-propanol. As an alcohol, it's based on the name propane, but we drop the E and add OL. So it was based on propane. We drop the E and add OL. The first step that we're going to do here is called a mild oxidation. The product of a mild oxidation of a primary alcohol is going to be an aldehyde. It's going to be an aldehyde that has 3 carbons in it, so I'm going to draw those 3 carbons. So this is a propane-based molecule, and then I'm going to draw the aldehyde functional group, which is the carbon double bonded to an oxygen, and then we have an implied hydrogen there. To name this, remember this is also based on propane. We drop the E and we add Al. So this is called propanal. Propanal. We go from 1-propanol to propanal. And we do not need to say that the aldehyde is on carbon number 1 because it must be on carbon number 1 because the aldehyde is always at the end of the chain because there's an H here. The next step is another oxidation because an aldehyde can be oxidized further to form a carboxylic acid. So our carboxylic acid will also be based on the 3-carbon propane. And then it'll have the carboxylic acid functional group that was converted from the aldehyde. So that's double bond to an O and then an OH. So when we name the product, remember we have 1, 2, 3 carbons, so it's based on propane. The E goes away and we add oic, and it becomes propanoic acid. Because we have formed a carboxylic acid. This reaction would be another oxidation, and we would refer to this as the complete oxidation. And it's of a primary alcohol.